we are going to discuss ultrasonics. That comes in the fourth module of your syllabus. Module 4 is acoustics and ultrasonics, and the second part of that module deals with ultrasonics. So in the very first lecture, what I am going to take is ultrasonics, the definition and its properties, and one of its production methods, that is by using magnetostriction oscillator. Let us see what is ultrasonics. So based on the frequency of sound waves are classified into three different categories. The first one is called infrasonic waves. If the frequency of the sound wave, if it comes or if it is below 20 Hz, they are called infrasonic waves. If the frequency of the sound wave, if it is in between 20 Hz and 20 kHz, they are called audible sound waves. And we can hear those frequencies that comes within this audible frequency range, that is from 20 Hz to 20 kHz. Now the third one is called ultrasonic waves. That is, if the frequency of the sound wave, if it is above 20 kHz, they are called ultrasonic waves. Now, so this ultrasonic, that term, it comes from the Latin word ultra, it means beyond, and sonic means sound. So this ultrasonic waves, its frequency is always beyond the upper limit of audible frequency range. It is above 20,000 Hz or above 20 kHz. That's why they are called ultrasonic waves. Now let us see what are the properties of these ultrasonic waves. The first one is the frequency is very high, it is above 20 kHz. So it has applications in the field of imaging, detection and navigation. Now let us see some more properties. As the frequency is very high, it has a high energy content. Now ultrasonic waves needs some medium for its propagation. They cannot travel through vacuum. Just like an ordinary sound wave, these ultrasonic waves get reflected, refracted and absorbed. And that can be transmitted over large distances without any appreciable loss of energy. Then the next one is, if an arrangement is made to form a stationary wave of ultrasonics in a liquid, it serves as a diffraction grating, and it is called acoustic grating. We will discuss in detail about this acoustic grating in the third lecture. Now, ultrasonic waves produce intense heating effect when it is passed through a substance. Then if the ultrasonic waves are traveling through solids, the velocity of the ultrasonic wave, it is given by the equation V is equal to square root of Y by rho, where Y is the Young's modulus of the material and rho is the density of the solid. And if ultrasonic waves are passed through liquid, its equation is, velocity equation becomes V is equal to root of K by rho, where K is the bulk modulus of the liquid and rho is the density. Now we are moving to the production of ultrasonics. Ultrasonic waves are produced by two methods. The first one is called magnetostriction oscillator, and second method is called piezoelectric oscillator method. So in this first lecture, we are going to discuss the first one, that is magnetostriction generator or oscillator. So first of all, let us see what is the basic principle of this magnetostriction oscillator. The basic principle is called magnetostriction effect. That is, if a ferromagnetic rod like iron or nickel is placed in a magnetic field parallel to its length, the rod experiences a small change in its length. This is called magnetostriction effect. So, if it is a varying magnetic field, the length of the ferromagnetic rod also changes. So let us see this diagram. in a magnetic field, then it is seen that if the strength of this applied magnetic field increases, then the length of the ferromagnetic rod increases. If it reduces or decreases the strength of the applied magnetic field, the ferromagnetic rod contracts. So continuously there will be an increase or decrease in the length of the ferromagnetic rod. That means we can say that oscillations will set on the ferromagnetic rod, and that effect is known as magnetostriction effect. And it depends upon the strength of the applied magnetic field as well as the nature of the material, and it is independent of the direction of the magnetic field applied. Now here, this shows the circuit diagram or the construction of the magnetostriction oscillator by using a ferromagnetic rod X5. Now, in the following slides, I explained the construction as well as the working of this magnetostriction oscillator in detail. So, I am going to explain with the help of this circuit diagram. So, just go through that slides too. Now, on the basis of this diagram, I am going to explain that one. So, see this. Here, this X5 denotes a ferromagnetic rod. This ferromagnetic rod is clamped at its middle. This is just a clamp to fix that ferromagnetic rod. Now, there are two inductors, L1 and L2. That one is surrounded over this ferromagnetic rod X1. Then, there is one variable capacitor, C, that is connected parallel to L1 so that it forms a tank circuit. Here, this is an NPN transistor. So, one side of this coil L1 that is connected to the positive terminal of the battery through this milliammeter. Then the other side is connected to the collector terminal of the NPN transistor. Now look at this coil L2. One side is connected to the base of the NPN transistor and the other side is connected to the negative terminal of the battery. Then the emitter of the NPN transistor is grounded. Okay. Now, let us see how this works. So, when the circuit is switched on, the capacitor charges, then it discharges through the coil L1. So, that will set vibrations on this tank circuit. So, this LC circuit that oscillates with a frequency F is equal to 1 pi 2 pi into square root of L1C. It oscillates with the frequency. Now, the alternating EMF on this coil L1 that induces a magnetic field on this rod. Okay, so if there is a varying magnetic field, what will happen? We know that the basic principle of working is magnetostriction effect. So surely this ferromagnetic rod, it undergoes oscillations. That means there will be continuously, there is a decrease as well as increase in the length of the ferromagnetic rod. Okay, so due to this oscillation of this ferromagnetic rod, that produces an EMF in the coil L2. Now see this coil L2 is connected to this base of the NPN transistor. So that EMF is fed to the base of the transistor and then to the tank circuit. That EMF is amplified here at this collector terminal, and as it is connected to the tank circuit, it is fed to the tank circuit. So this EMF, it is used to provide a positive feedback, and that overcomes the loss of energy in this tank circuit and it maintains an oscillation. Okay, now see this tank circuit, here there is a variable capacitor C. So just by varying this capacitance C, we can change the frequency of the tank circuit. Now, by varying this capacitance value C, the frequency of oscillation of this tank circuit, we should make that frequency of oscillation which is equal to that of the frequency of vibration of the ferromagnetic rod. frequency of vibration of the ferromagnetic rod, which is given by the equation F is equal to 1 by 2L into square root of Y by rho. That should be equal to that of the frequency of oscillation of the tank circuit or LC circuit. That is 1 by 2 pi into root of L1C. So that is called resonance. So when both these frequencies becomes equal, this rod, it oscillates with its maximum amplitude, and at that time ultrasonic waves are produced from the ends of the ferromagnetic rod. So this is how ultrasonic waves are produced by using a magnetostriction oscillator. So all these are explained in detail in these slides. You can go through that one. Now let us see what are the advantages of this method. Advantages: the design of this magnetostriction oscillator is very simple and its production cost is also low. Then at low ultrasonic frequencies, very large output can be produced without the risk of damage of the oscillatory circuit. Now let us see what are the disadvantages of this method. By using this magnetostriction oscillator, we can produce or generate ultrasonic waves only up to 3 MHz frequency. So beyond that, the production is not possible by using this method. That's why we adopted a second method called piezoelectric oscillator that we will discuss in the next class. Now, the another disadvantage is that the frequency of oscillation depends on temperature. Then there will be losses of energy due to hysteresis as well as eddy current. So by this, we come to the end of the production of ultrasonic waves by using magnetostriction oscillator. So by this I am winding up the first lecture. Thank you all.